All right, so this morning what we're going to do is we're going to solve City of Chicago, this challenge that we wrote. It's using SQL, it's reading CSVs, it's doing a lot of Python stuff. So it's a nice mix of everything that we've done so far, and it allows us to really use real data to try to come up with some sort of, some sort of argument of, what we can figure out from there. We're going to go until 12:30, and we'll see where we end up. So I'm going to clone this down first. Go onto my desktop. I'm going to clone down the City of Chicago stuff. City of Chicago. And of course, I'm going to check out to a new branch. John's solution for India. All right, so let's read through this. We're going to grab a live data set, so it's up to date, parse through the columns, clean the data, and insert it into a database. And after that, we'll query the database and find some important data points. All right, so number one, it says just get this data set and download the CSV. So I'm going to visit the portal. And I believe I can download, export. Oh, export as CSV. And it's going to move over there. So I'm going to just grab this and move it inside here. So I'm going to move the downloads, what was it called? Current employee, to where I'm at right now. And you can see that it's right over here. I'm going to call this something different, so I'm just going to rename it. I'll call it Chicago Salaries. All right, so I've downloaded it and I've done release number 0. So second, it says create a database using Psycop. I want to create an employees table with these following columns: first, last name, job title, full or part-time, department, and annual salary. Okay, I don't know how to do that. Your code goes here, that's not helpful. I don't know how to do this off the top of my head, so I'm just going to copy and paste it from yesterday. So let's go into yesterday's curriculum and just copy and paste a bunch of stuff. Where's the last one? Okay, I'm just going to grab this here and throw it in its place. I'm going to start from the top, and my thought process is I'm going to comment out everything I know that I don't need right now. I might need it later, but I'm just going to comment if I don't need it. I probably need CSV to read it. I probably need Psycop. I probably need operating system. These I will comment out for right now because I'm not sure that I need it. And this table creation query I probably will need. I'm probably going to need to alter this. I'm probably going to need to clean the data, but for now I'm just going to comment it out. I'm going to click this just to make it a little bit smaller. So first things first, what should I do? Create a virtual environment. Okay, so I create a virtual environment because I need to install things like Psycop inside of there. So how do I do that? Okay, Python-m them. So the way that this reads is, hey, Python, make me a virtual environment called virtual environment. I can call this anything I want. I can call this poop, and it will create me a virtual environment called poop. I'm going to rename that, but you get the idea. Next, since I created the virtual environment, and that's just kind of like, remember Bubble Boy, like the greatest movie of all time? Bubble Boy was enclosed in a lot of bubble wrap, and he was able to walk around. The outside world doesn't impact him, and he doesn't impact the outside world. The same idea applies here with this virtual environment. I created a bubble wrap around this particular repository so that whatever I install doesn't affect my outside computer, and my outside computer stuff doesn't affect what's inside. The way that I activate it is going to use source, bem. Inside of there, there's a bin folder. Inside of there, there's an activate script. I don't know what's inside of it, so source vem bin activate, and you can kind of see. Oh no, it's called poop. Whatever. This, I've activated a virtual environment, and I can actually install stuff now, and it won't affect the rest of my computer. I believe it's pip install Psycop G2, and it's already done. Nice. I guess I don't need to do that. So I'm looking through this table creation query right here, and it says create table properties. Based off the README, it says I need all of these things inside of there, and it's called an employees table. All right. So I'm going to just paste this inside of here, comment it for right now. Create a table called employees. The ID number is going to just be fine there. I'm going to have first name, last name, job title, so on and so forth. Job title. Annual salary, we'll save as an integer. Why not? Let's see, did I miss anything? So I've got a table called employees, an ID number, first, last name, job title, full or part-time, department, and annual salary, which is going to be probably not. Should we just do a whole number? Decimal?
Department.
Oh. There is a money one. Let's not use that one.
You have to convert.
Yep. So I've got the table creation query. It's safely nestled within this Python method. And so in the case I ever need to update it, it's easy to find it and update it. Next, I need to connect to a particular database. I haven't created one yet, so maybe we'll call this Chicago salaries. And we're just going to execute the table creation. I don't think I need this right now. So let's see what we have. We're importing CSV, which we don't need yet. I'm importing Psycop, the operating system. And I'm going to connect to the Chicago salaries database, create a cursor, and execute this table creation query, which we all agreed was, it's SQL, but it's good. We're creating an employees table.
So later on in one of your challenge questions, you have full-time and part-time.
Yep.
So I didn't know if we would need to actually create two variables for that, like we did for first name and last name.
We'll just keep it as one. Maybe just at full time. Maybe we'll just type in full time or part time, or just F and P.
Yeah.
Bobby.
Cursor.
Cursor.
What does a cursor actually do?
I have no idea. Underneath the hood, this is what they told me to do.
Okay.
So I'm guessing it creates an open connection to the database. Inside the connection, there is a cursor object in there. The cursor is the thing that basically allows you to execute commands. Okay. So it's not just the fact that I open a connection. The cursor is the thing that allows you to execute commands. That's all I know.
Actually, I use get login too. I just copy and paste like this.
Yeah.
But I don't really understand the get login to this.
Me neither.
Oh.
Yeah.
Great.
I'm guessing so the OS is a library that's built into Python. I'm guessing it stands for operating system. Get login is probably saying like, get me the user that's currently logged into your computer. That's my guess, but I don't always know. Yeah. All right, so I think this should be good. If I run this, it's going to execute the table creation query, commit it to the database, and then close it. So the first thing I need to do is drop DB Chicago salaries, just in case it exists. It doesn't exist, fantastic. So first thing I need to do is create it. It's empty. If I look inside of P-SQL of Chicago salaries, and I do \D for all the tables. There are no tables because it's empty. From there, I'm going to run chicago.py, running Python chicago.py. It runs through. It doesn't have anything that blows up. So let's go back inside the database, Chicago salaries. If I do \D, I've got employees inside of there. If I do \D with employees, hopefully I'll see everything that I wanted to. This is gross. I'm going to do \Q, \X. Nope, it's still gross. All right, so it looks like over here I've got a first name, last name, job, department, full-time, part-time, annual salary.
Does \X change the view?
It does, but I think the \X is for when you're retrieving records, because otherwise this would look better than what it looks like right now. Right. So we feel comfortable with creating the database and using Psycop so far.
Just one quick question. Oh,
Yeah,
no,
Hank, go ahead.
So I noticed on that table, like it didn't, all of yours didn't matter if they were null.
Yeah, as of right now, you can put in things if you can have a null in there as well. I didn't specify that inside of
then
my.
that was just a simple not null.
Yeah, and that, if I wanted to, I just do not null for all of them. Ollie,
That was
same question. Okay. All right, so let's take a look at what we have to do next. This is where it starts to get really difficult. So release 0 and release 1 are pretty simple. Now we have to clean and we have to read and insert the data. So in this release, read the CSV file, iterate over each row, clean the data, and insert the clean data into the database. Note the calculation for annual salary. Keep an eye out for two things. We want to name first name and last name split into the database, but it just has one name field. Is there a way to easily parse this out? Probably not, but we'll take a look. And then finally, they read numbers as strings. So I believe this is where, I'm going to \Q out of here. This is where this thing comes from. I'm just going to uncomment this, and I'm going to open up the correct CSV file, which I believe is called Chicago_salaries. And then I'm just going to get rid of all this for now. I know I need to clean the data a little bit later, but right now it's just a empty commented out method. I'm just going to throw in embed. I don't think I need to connect to the database yet, so I'm just going to comment all this out. And I just want to run this so that I get to the first one. So I'm going to clear the screen. Python chicago.py. All right, CSV is not defined. Oh, good call. Save this and run it one more time. Clear. All right, so I'm stuck inside this embed. I believe Chicago salaries to be 33,000 lines long, so I'm going to have to stop this at one point. But let's just take a look at row. So row is an ordered dictionary, and I want to be able to have a few things. First name, last name, job title, full or part-time, and department. So there's a few things I know I can do quite easily off the bat. Probably job title, full or part-time, and department. Those are things I can get for free. My thought process here is let me just be able to access those things. So if I can do row of job titles, and you can notice I'm just copying the key over here. Can I access sergeant? Perfect, I can. So that one is pretty simple. I'm going to throw this inside of clean data, and I'm going to pass in an entire row. So I'm going to get rid of everything here. We just have an empty object, and we're returning that empty object. So if I do clean job title, I'm going to set that equal to row, CSV row, at job titles. Make sense? Making a key called job title, and then accessing row job titles. What else do I need? Oh my God, there's so many of them. Job title, full or part-time, and department. Full or part-time, it's right there. So I'm just going to copy this whole thing. If I do row of that, I get F for full-time. So pretty simple. Full or part-time is equal to CSV row with this thing over here. Continuing on with department. Looks like it's just capital D, department. And the way I need to check. I need to verify that I can actually do this. Okay, that one works for me. What else do we need? Job title, full or part-time, department. So I think we took care of the easy three. Those are directly here on the object itself. And now we need to figure out this weird thing with the name. So the name is the next thing I want to tackle. So if I do row of name, I get a lot of strange formatting. Let me exit here, move on to the next person. If I do row of name again, you can kind of see that I have last name, comma, and then a number of spaces, 2 spaces, the first name. So I know there's probably some sort of regex that I can do. I can probably capture everything before the comma and save that as last name. And then space, comma, space, space, I can ignore. And then the one at the very end, I can grab their first name. I don't know how. Row, yep.
So, me and Christian were talking about this. Some have middle names. Would that be okay just to leave within the last name, or how would...
So yeah, actually, I had this issue the other day when I was booking a ticket for London for my dad. First, middle name is actually just a US thing. It's actually all part of your first name when you register on your passport. So I'm just going to make the assumption that it's going to be your first name is your first name plus middle initial.
Right.
Just for the sake of ease, I
And
suppose.
in the data, there's also sometimes suffixes in the third or junior, senior,
Okay.
In the last name part.
Oh, interesting.
Would we leave those in, or?
I would say just leave those in as last name.
And multiple last names.
But I think in general, if I'm not mistaken, if I look at the salaries over here, most of them are going to be like this.
Yeah.
But the way that we can tell for sure is it looks like all of them follow this pattern. Last name, comma, anything, and then I'm going to say everything else is first name.
Should be split by comma space splits.
Yeah, maybe I can do split, row, name, split on the comma, space, space. And I think that's it.
Well, sometimes
I didn't even
there's...
have the spaces.
Yeah. Well, you can just not trim it. I just knew it.
If you do this, then your first name actually has 2 spaces in the front.
Right. I did 3 splits, right? So
Okay.
the problem, there's a problem with different names if you have like a forward or whatever.
Yeah.
So for last name, I just split the comma, take the first element. It's always going to be the last name.
Cool.
And then for the first name, there's a bunch of different conditions that go with it. So I split the comma and then split again from the second element, because you know you only have 2 elements. Every name only has 1 comma.
Mhm.
I took the
Every row has 1 comma.
yeah, every row has 1 comma. Then I split again at the space and took the index 1. And that works for every
Cool.
case that I ever saw.
Let's tackle that when it comes. For right now, I'm just going to stick with this for now. And I'm going to save that inside of here. So I'm going to do cleaned of first name is equal to CSV row at name dot split at the comma space space at index 1. That's the last one over here. And the same thing with the last name. I'm just going to take the first one. I'm sure this will break at one point. We'll deal with it when we get there. So I think that's how we take care of the naming situation. We know that it's always going to have comma space space, because according to, if I just spot check it, this one has a comma space space, and I can just highlight that a bunch of times. You can kind of see every single one of them share that comma space space. All right. So I took care of first name, last name, job title, full or part-time, department. Now this is the challenge. With this, now we're coming to annual salary. So if I take a look at row, it looks like there is annual salary. For most people, it's pretty simple. If I just do row of annual salary, I get a string. I can probably turn that into an integer. Did we say float? Decimal? Is it decimal? Decimal is not, so I need to import decimal.
Oh, you have it.
Oh no.
You read it.
Oh, yeah, from decimal, import decimal. Cool. And this is like a decimal object, but underneath the hood, it is turning that string into a number with decimals at the end. I think this will work for most of them, and it will definitely blow up because I saw this happen yesterday, so we'll tackle that when it comes. So, but for now, I can do return cleaned of annual salary is equal to CSV row of annual salary, and I know that I can decimalize this whole thing. I'm going to stop the embed at this point, and I'm going to undo that one. Yeah, I think this one works so far. So we have a creation for the table. We cleaned the data up over here a little bit. And let's connect to the database. We don't need this because we already ran it. And now I want to start throwing things inside the database. This is where it starts getting a little bit messy. For row and CSV reader, I'm going to have clean data equals clean data of row. I'll call this cleaned data. Now that I have the clean data, I need to insert it into the database. And I think that's this giant thing over here. Insert into properties, and this huge thing. Cursor.execute, insert into employees. ID, first name, last name. I'm going to just copy this whole thing, paste it down here so I don't have to jump back and forth. First name, last name, job title, full or part-time. No, I'm inserting it. No, so I just put this down here so I don't have to scroll up and down. That's all. Full or part-time, department, and annual salary. Gotta get rid of this. Insert into first name, last name, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So everything from here on after I don't need. And now I have the clean data of first name, clean data of last name, clean data of job title, full or part-time, department, and annual salary. Please do not blow up. All right. Also, because we had this issue yesterday, some people were like, "Is this running? Is this not running?" I'm gonna have a like I equals 0 on the outside here. Probably over here is okay too. Probably over here is okay too. I'm just going to print, and then print F. I'm going to say 1 actually. Row 1 of, I think it's 32,692. 33,692. Done with row I of 33,000. Does what I did make sense so far? So I read the CSV file, I'm getting the row, I clean the data using this method that we created together, and then I'm going to insert it into the employee's database. See if this works. Oh, yep, you're right. And then I plus equals 1. Let's see if this works. It's definitely not going to work. Clear, Python, Chicago. Go. Okay, there it goes. So I did 1, 2, 3, 4, 5, and then it blows up. It completely blows up after row 5. So if I take a look at number 6 here, 1, 2, 3, 4, 5. That means on Reese Abascal, oh, it looks like he's a traffic control aide, but this person is hourly, and then they don't have a like an annual salary. So if you see, it goes salary, comma, nothing's, comma, the annual salary itself, and that one is empty right over here. So if there's nothing inside of there, what do we do?
Well, we need to handle the part-time and full-time. And that will exist or not exist.
Sure.
I actually created a function for annual salary.
Okay.
And said if it was empty,
Yep.
then take the hourly, because it has access to those rows too. Just take the hourly row and multiply it by the hourly or the hours and times 50 and make that be the annual.
I'm confused why it blew up. So when I ran mine, it went through and just put an empty string in those spots first.
Probably because you set it up differently.
He's converting.
I'm converting it to a decimal, so I can't convert an empty string into a decimal.
Yeah. I use mine.
Cool. So the second to last thing is annual salary. Because number 6, the Sabasco fella, doesn't have an annual salary, that's the second to last one over here, it blows up. So I need to tackle that in some way. So Holly had a great idea, which was to figure out the annual salary, it's figure out annual salary, and then I'm going to pass in the entire, pass this in. She said, let's create an actual method to do this. I said, okay, let's do that. I'm going to create a method called figure out annual salary. It's going to take in some salary. Actually, we're going to pass in the entire row.
Yeah.
Yeah.
Yeah. Just take some. What takes in all the rows?
No, just one. I would just do one row at a time.
Oh yeah.
Yep. So if the CSV row has something called, actually, let's,
My thing was annual salary is equal to an empty string. That's
Yeah. Okay, that works. If the CSV row at annual salary is equal to an empty string, how about this? If it doesn't equal an empty string,
Well, it's already doing when it doesn't equal, it's giving you annual salary.
I'm. This is the way that I would think about it. So, that's it. Okay, and then otherwise, if it is an empty string, then we have to figure out a whole bunch of stuff. So let's take a look at this fellow. We have this person here with these particular things. All right, so it looks like we know this person is salary or hourly. It looks like part-time, maybe are all part-time people hourly? No?
If you looked at the actual, I just looked at the CSV.
Yeah.
And if they were hourly, the annual was empty. So
Okay.
that's why I just went with that, because it didn't have anything in all the annual. So I got all my back, right?
You found that real estate person was technically full-time, but somehow we did the
That's why I didn't
Okay,
use
so-
So
At this point, I'll get to you because I need your answer, actually. So at this point, we would probably have to find other like similarities here. Like this is as clean as data will come. Like this is pretty good, pretty decent for 33,000 people. They've done a pretty decent job. So someone actually had to input all of this themselves. But essentially, at this point, we have to figure out how are we going to figure out who is part-time? How many hours are they working? Like, is there something that's common? And I'm guessing you figured that out yesterday.
So if we want salary, right? There is no salary.
If there's no salary, I want to calculate it.
We want to calculate a salary. But that's all we really want. So
Yeah.
I just did it the same way. If annual salary equals a blank string, then yeah, every other time the person had regardless of if full or part-time, if annual salary is blank, they had a number of hours worked per week
Okay.
and a hourly rate.
Okay.
So I just took those two numbers and 50 and multiplied them all together.
Okay. So we do 50 times CSV row of typical hours times CSV row of hourly rate. I don't know if this will work for all of them, but if it doesn't, that's okay too. We'll figure it out from there.
I didn't find any
The description,
It might be
the description of the data said that in every case when we come in, we provided these two numbers.
Yeah.
So
I think this one works. So we have a method here to figure out the annual salary. It's down over here. So if there's If it doesn't equal an empty string, then just return it because you know that you have an empty salary. Otherwise, calculate it based off their typical hours and their hourly rate. I think this might work. We'll find out. So let me drop the database, Chicago salaries. Let me recreate it. Chicago salaries. And then now I'm going to come back over here and reinsert this table creation query here on line 28. So I dropped it, I recreated it, there's no table in there, and I'm gonna run it.
Can you go back up to your math for the hour, the weeks? So I think now it's just investment, hours.
Oh, int.
Well, hourly rate is a decimal, or is it float?
Is it, no, hourly rate is a string. Oh, okay, let's do this.
Decimal.
Typical hours equals decimal of CS row typical hours. That's a good catch. And hourly. Yeah, I know.
That's not great. Well, I guess no, there's a number that would be. It's multiplied by 2 strings, so. Like 50 times a string, which is multiplied by 3.
Yeah, 50 times, yeah. We'll see if this works.
52.
And then you would decimal
a
that.
year.
There's 52 weeks in a year, but you generally have 10 days off for federal holidays. I figured.
So,
Maybe we can argue this to the answer there. I'm going to say 50 for now. We can change it to 48 if you want. Go. Go.
yeah. 52. Oh, that's insane. It really slows things down.
What's that?
Insane. It really slows
It does, yeah. Well, it means printing, right? All right, so I think we might have done it. This is how I keep track of things as well, so I just print it out. Hey, it looks like we finished it. So it looks like I'd inserted all those things correctly. If it works out well, let's jump into eSQL Chicago salaries. Let's do select count from employees. Hopefully we get all of that. 33,692. And if I jump down to the bottom here, not including the header, it's 33,692. So we've inserted all of our stuff correctly. So we've basically figured out how to do first name, last name. We've figured out a little bit about the salary portion here. Let's try to get some of these things out of the way. Find the employee being paid the most. So this is some sort of pretty simple SQL query. I'm just going to grab this here, throw this inside of Chicago queries. This. All right, number one, figure out the employee being paid the most. Thoughts?
Do it descending.
Yeah. Select star from employees, order by annual salary,
Yeah.
descending, limit 1 to get the top one. \x. Okay. Jamie L. Ree is the Commissioner of Aviation, being paid $275. Well, that's a lot of money. Well, okay. All right. Same thing here. Who's getting paid the least? Change it to ascending, limit 1.
Yeah.
You do.
I can automatically send.
Maybe.
I
I'm just gonna
can't
be-
ask that question.
Let's find out. Let's see what we get here. All right. Betty L. Abbott, foster grandparent, is only getting paid $26.50. Okay. It looks like if I don't have a condition here, it'll automatically go by ascending.
I
So,
can ask that question.
okay. Let's see. Let's just verify. Same thing. All right. Find the department with the highest average salary. Ooh. So this one is going to be a little bit different because I need to find all the departments, and then I need to find all the actual values as well. So this might be a place where I want to do a little bit more Python involved as well. So these two are really simple. Find the department with the highest average salary. I'm going to start doing some Python stuff here. Essentially, I need to find all departments. Probably create like an object with like the family and support, and the average is like, I don't know, $5,000 or something like that. And I basically have to create a giant dictionary of stuff. So how do you want to tackle this? You could do this all in SQL, but it takes forever. You did that? You did all?
Especially number 8.
Is there a finite amount of departments?
I don't know. Let's find out. How do I tell? Select count. Select count for a department from employees. There are. I need unique. Unique. How do I?
Everybody has it.
Is it select distinct? I don't know. Select distinct. SQL. All right. W3 schools. Select distinct. Oh, nice. Select distinct. I don't think I need the count, so let's select distinct department from employees. All right, that's a lot of them. Let's actually just do the count. That's not what I wanted. Yeah.
We put the distinct on the other, like the count on the other side of the distinct. And then
Like that?
Yeah, and then the count.
Let's find out. 36. So there are 36 of them. So we can.
While you're iterating through your row, you append them to a dictionary and count how many are each in each property.
We've already inserted it though. I don't want to reinsert and stuff. So using what we know already, how do we tackle that? Christina?
One, and I came up with a solution for finding the highest average salary, and it was using SQL, which was select department, average, and then the parentheses annual salary, from salaries grouped by department, ordered by average, and parentheses again annual salary,
Yeah.
and then just setting one.
This is pretty good. I mean, can you send it to me on Slack so we can
Yeah.
taste it?
My number 5 SQL is a giant mess. It looks like the ugliest damn thing.
Yeah, but now you know SQL a little bit better.
Yeah.
Did you send it to me?
I just put it in India's.
Let me open up.
Question?
Yeah.
So I know you guys are all using the with and inserting it directly after you open it, you put it in that dictionary directly.
Mm-hmm.
I saw benefit in kind of segmenting a little bit more, where I would store local dictionaries, 33,000 of them, so I would have it, and then have another method to insert them into my database. What that allowed me to do is stuff like this, where I can go to my local and calculate.
Yeah, that is another way of doing it. But I've already, that's why I said,
I know.
if I've already inserted it, I
Yeah.
don't want to redo it all over and over again. So you could do so it's not join table because I'm not joining anything together, but I can create a view. Yeah. Let's take a look. This did not work. From salaries, from employees. So select department, average of the annual salary from employees, group by department, ordered by, actually that's pretty good. There's only, select department, limit 1. Okay, so you only took the top one. So the Department of IT on average makes $106,000, pretty decent. Let's take a look at all of them, actually. I'm interested in all of them. All right, so IT makes 106, buildings makes 104. What about the last one? There's only 36 of them. Family and support. Oh no, it's the foster grandma we saw earlier. $43,718. So from real data, we're able to figure out if you were to work for these particular departments, this is how much money on average you would make. That's pretty cool. What about the lowest average salary? Well, this is pretty simple. We just don't do descending. And if I just copy that, you'll see my number 1 is that family and support. What is OEMC? I don't know. Emergency something. Find the average salary difference between full and part-time workers.
Limit 1.
We could limit 1, yeah, that's fine. Find the average salary difference between full and part-time workers.
So I did a subquery. So I did a query for the average full-time.
Yeah.
And then a pretty much just assume that the average for part-time is going to be less.
Yeah.
And just use this subtract operator.
Yeah.
And
Divided by 2.
inside
Okay.
of another query, like select all
Cool.
from.
Do you have that handy? You can send me? While we're waiting for that one, let's find the most common first name.
Oh,
I don't know.
it's the same
SQL.
thing we did for
Yeah,
departments.
just do the
Same thing for departments? Okay.
Or we were just trying to, we're messing around counting.
Okay.
It's kind of the same thing.
Is it just select
I didn't know we did that.
select first name from employees? That's,
Select count.
But then you can hit at the end.
Distinct.
like that? I don't know. Let's find out. No.
We go up and see
Might be that.
like, yeah, go back to the log again.
I do. It does work here. This one? Distinct.
Yeah.
Count
Yeah, we have the
distinct.
same thing right there. Yeah. No, that's, how do we get the first one?
Right.
If you do, I think if you use what the simple by instead at the where it's like group by first name, and then yeah, and then count, and then return that as like it's closer to what she did with the
Yeah, I
departments than it
realized
is
that
to
after I
that.
said that, 'cause
Yeah.
we missed the step.
Oh my God. There's so many of them. Order by.
But there probably won't be that many matches though, right?
I think
Because
I
when
think
we did the
you
middle initial in there,
maybe group by and distinct you should
it'll be like Kevin J as opposed to like just Kevin.
Yeah, that's another limitation of what we've got here. Group by. What are we grouping by?
first name.
Oh,
We want all the first names that are similar to count.
Yeah, absolutely.
let's Google it. SQL query. Most common value. Most frequent value in SQL column. Select column, count column from group by value occurrence. Okay. Let's take a look at this and see what we get. This here. Select. Okay, so it's I think it's select first name. Count first name. I don't need value occurrence here. First name. From employees. Group by first name. Okay, I guess I do need that value occurrence as something. Order by something. Sending. One. Let's see if this works. Okay. What did I do wrong? Oh, I don't think I need something. Michael J. We'll count this as occurrences. Yep, Michael J. is the most common first name. And if we were to do the same thing with last name, it's what's that? Michael J. Fox. What about the last name? Who's got the most common last name? All right, Williams is the most common last name with 287 people. if there are people with the same name, what are their job titles, departments, and annual salary? That's going to take too long. Do you have that that one that you were going to send me?
Yeah. Oh, I sent the one. I can send you both.
Okay, this is fine. Let's take a look. Let's take a look at this.
The 8 or the 5 won't work.
Oh my God.
Money. Because I use money. Okay. But the number 8. It's on Indeed.
Can you walk us through this?
Like I said, it's one really ugly query for finding the average salary of full-time employees
Okay.
using subtract operator.
Okay.
So just subtract the
I guess.
query of part-time, and then it's in both of those are within a query, so just display that. Yep, I played with it for a while until it worked. But it's not going to work because the numeric, I had to change annual salary to numeric because the average won't work on the money type, and then I changed it back.
I see it. So what Christian is doing here is he's got a query right here to basically figure out what's the average if you're a full-time employee. And then the result here is being saved as under this select. Then from there, he's finding all the ones where it's part-time. Subtracting those two, you take the average of the first one minus the average of the second one, saving that one as average diff in salary between part and full-time, and then from there, he's figuring out what the actual difference.
Also, the limit ones, for some reason, the calculation kept happening and it just kept printing. Like, I thought it would only do it once.
Yeah.
But it would just keep printing the answer, the same thing, infinitely.
Yeah.
So,
So you could do this. You could do this a couple ways. One of them is that you can do giant SQL queries like this, and this is very impressive because I wouldn't do it this way. The other option here is that you do stuff with Python. So this one is you can basically say like full-time workers salary is equal to I don't know, basically some sort of method. The method would read through all of the rows inside the database, get the full-time salary get the salary for all full-time people, add them together, and average the count, and then subtract that from the same thing but with part-time, and then you can solve it using a Python method. But you could also do it just purely with SQL like this.
If you did that, then you would you just copy everything that you wrote Python, paste it down into the.
You wouldn't do it in here. You would run it from here.
Okay.
So then your method would have a bunch of those connection things inside to get things out of it.
Yeah, so you would execute a particular query. You would save that result inside of a Python object. That Python object you pass into a method. That method calculates the average, and then you get that result. Okay, so it's 12:30. I think we got through most of it. There's like the most difficult ones over here. Obviously, we didn't get to with enough time, but I hope this was helpful in some way. Let's stop the recording here.